Okay, so hoping you had a chance to think through this. So now let's work it out. So let's first start with this this circuit and see what happens when we connect with a potential with a battery. So this battery has potential difference V. What will this do? It will basically try to push positive charge from this side and negative charge from this side. So there will be some charge going in here, right? And each of these surfaces, so let me call this one, let's say I'll call this A1, A2, right? This is my A3, A4, and this is my A5, and this is my A6. These are the names I'm giving to the plates of the capacitor, right? Now each of this A1, A3 and A5, right, they would get some charge. How much? Let's call this charge Q1, Q2 and Q3, right? And correspondingly the other plate would have the same charge but negative, right? This would be minus Q1, this would be minus Q2 and this would be minus Q3. Okay. Now, in case you're wondering, why would this be exactly balanced? Because once you have some charge here, right? This Q1 would attract the electrons. So the electrons here in this wire, they would get pulled until the field outside is 0. When both of them have Q1 and minus Q1, then the field outside is going to be 0, right? So therefore, each of the different plates of the capacitor would have the same charge but opposite sign. Okay. So now, if this is equivalent to this, which means when I connected with potential V here, Q charge went in here, which means here also if this is equal to this, then when I connect with the battery with potential V, total charge flowing in here would be Q. Total charge, right? Total charge flowing in here, in this whole thing is going to be equal to Q, which means my Q is equal to Q1 plus Q2 plus Q3. Okay, so now what is my Q1, Q2, Q3? So look at each of those capacitors. So we have this we have C1, C2, and C3. Now what is it that is connecting the charge to the capacitor? Right? So it is the equation Q is equal to CV. Right? Now look at this. What is the V for each one of them? The potential V. So which means these 2 points have potential V, which means the potential here is V, V and V. All the capacitors have the same potential across them, right? Now, if that is the case, then I can say that my Q1 is going to be equal to C1 into V. Similarly, Q2 is going to be equal to C2 into V and Q3 would be equal to C3 into V, right? So these are my equations 2, 3 and 4, right? Now what do I know? I know that if this circuit was equal to this, right, then this Q would be, as I said, this would be equal to the total charge here, and then this C is going to be the C effective, right? So I'll say from this circuit I'll say that Q is equal to C effective, right, into V. Now just put these values, this 2, 3, 4 and this 5, substitute 2, 3, 4, 5 into 1. So what do we get? So what we get is, we get C effective, right, into V is equal to Q1, which is C1V, C1V plus C2V plus C3V, right? Now as you can see, V is common, so I can say C effective is equal to C1 plus C2 plus C3, right, into V, and sorry, there's a V here, and now I can cancel these two V's, right, divide them both by V, and now I have my answer, which is that C effective, the effective capacitance or the total capacitance is nothing but equal to C1 plus C2 plus C3. This is a very, very simple, very beautiful result, which means that when you connect the capacitors in parallel, we just add them up. The capacitance, just add them up. Thank you.